Molar mass. Molar mass is the mass of 1 mole of any substance. It equals the relative atomic mass of a substance, or if it's a compound, the relative molecular or formula mass of that compound. So, a little bit of revision. And if you haven't watched or learned anything about relative isotopic mass and mass spectroscopy, have a look at those videos before you continue with this. Okay, so 1 mole equals 6.02 by 10 to the 23rd of anything. Okay, so when you're counting atoms or molecules, because they're so small, we give them we say that 1 mole is equivalent to 6.02 by 10 to the 23rd. It's simply just a counting tool. So relative atomic mass. Relative atomic mass is the average relative isotopic mass of one atom. What that means is if you work out the relative mass of the first isotope of the atom and multiply that by its abundance and add that to the second isotope's relative mass times abundance, etc., and divide that by 100, you will get the relative atomic mass of that atom. So relative atomic mass is found on the periodic table. If you have a look at the periodic table, it's going to be equivalent to the mass number. So the relative atomic mass of each atom is equal to the mass number on the periodic table. Relative molecular mass is just simply the addition or the sum of the relative atomic masses of each atom in that molecule. So let's look at an example of carbon dioxide. Carbon dioxide is made up of 1 carbon atom and 2 oxygen atoms. So to find the relative molecular mass of this compound, all we need to do is look at the mass number of carbon and the mass number of oxygen, because that will give the relative atomic masses. So we've got 1 carbon, so it's 1 times 12, because that's the mass number of 12. 2 oxygens, so we'll have 2 times 16, because 16 is the mass number of oxygen. And we add those together, 12 plus 32, and we get 44. Okay, if that's all very confusing for you, please go back and go over a relative isotopic mass and relative atomic mass. Otherwise, let's keep going. So, molar mass equals the mass of 1 mole. Now, remember that moles of substances have different masses. So here we've got table salt, we've got sugar, we've got salt, we've got some carbon, and some copper and some helium. All of these have got different masses. There's 1 mole of all of these substances, but they've all got different masses. So the molar mass is equal to the relative atomic mass or the relative formula mass. And those are, of course, the numbers that you find on the periodic table, which are the same as the mass numbers. So molar mass you can work out just by looking at these mass numbers, because it's the same as the relative atomic mass for 1 atom or the relative molecular or formula mass if it's a compound. So molar mass unit-wise equals grams per mole. It's how much does 1 mole weigh. So it's how many grams 1 mole weighs. This can be written as grams per mole or as grams to the mole -1, which is exactly the same as grams per mole. You'll see this written a lot of time, and you'll probably start writing it that way as well. So when we're looking at mole, if we say 1 mole of carbon, it has a mass of 12 grams exactly. Remember, this is what the whole relative atomic mass is based on, is carbon-12 having a mass of 12 grams. 1 mole of copper has a mass of 63.5 grams. So the molar mass of carbon is 12 grams per mole. The molar mass of copper is 63.5 grams per mole. Okay, so an example. Let's have a look at methane. The molar mass of methane will equal the relative atomic mass of carbon, because there's one carbon, plus the relative atomic mass of hydrogen times 4, because there's 4 hydrogens. Where do I get these numbers from? From the mass numbers on the periodic table. So 1 times 12 plus 4 times 1. Now remember, you've always got to do your multiplication first. Remember BODMAS from maths. So that equals 12 plus 4, which is 16. Remember your units. Your units are essential. Grams per mole. That matches what our molar mass should be. Example 2, glucose. The molar mass of glucose is 6 times carbon's relative atomic mass, 12 times hydrogen's relative atomic mass, plus 6 times oxygen's relative atomic mass. We get those again from the periodic table. So it's 6 times 12, 6 carbons. Each carbon has a relative atomic mass of 12. 12 times hydrogen. Each hydrogen has a relative atomic mass of 1. And 6 times 16. Add those all together and you'll get 264 grams per mole. Remember your units. This is vital. Question 19. Determine the mass of 1 mole of each of the following substances. So I've got iron atoms, water, sulfuric acid, and magnesium hydroxide. You can have a go at these now, and I'm going to do the work solutions to the first 2. So pause the video, see how you go. So the mass of 1 mole of iron, that equals molar mass. So if we have a look on the periodic table, you'll see that iron has a relative atomic mass of 55.85. So the molar mass is equal to that number. There's only one iron, so it equals 55.85 grams per mole. Remember your units. 1 mole of iron weighs 55.8 grams. The mass of 1 mole of water. So the molar mass of water is going to equal 2 times the relative atomic mass of hydrogen, because there's 2 hydrogens, and 1 times the relative atomic mass of oxygen. We look at the periodic table again, and we'll see that the relative atomic mass of hydrogen is 1, so we'll need 2 times 1, and the relative atomic mass of oxygen is 16, so we'll need 1 times 16, which equals 18.0 grams per mole. This means that 1 mole of water will weigh 18 grams. So let's have a look at the relationship between molar mass, which is grams per mole, and mass and number of moles. If molar mass is grams per mole, it is grams per mole. So it equals mass divided by the number of moles. Now, using this relationship, we can determine any of these 3 if we know the other 2 values. Okay, so the way to remember this version here is molar mass equals mass divided by number of moles. The second way it can be flipped around is that the number of moles N equals mass in grams divided by molar mass, which is grams per mole. If you're mathematical, you will see that the grams cancel each other out and the moles on the bottom, so if you flip that up to the top, your units are going to be equal to the same. But don't worry too much about that. This can be remembered as number of mole equals mass divided by molar mass. This is my preferred way of remembering it. And last but not least, you've got that mass equals the number of mole times your molar mass. So mass equals your number of mole times your molar mass. So here's your 3 different manipulated formulas here. Now the easiest way to remember it is if you put these into a triangle. Now if you haven't done this, this is a great way of figuring out how to rearrange your formulas. So moles at the bottom, mass at the top, molar mass on the other side here. So now if you want to solve for what n equals, cover up the number of moles here and you'll see that it equals little m on big M. Little m on big M. Let's look at a second one. So here we want to work out what big M equals, so molar mass. Cover molar mass and it equals little m on n. Little m on n. And last but not least, let's work out what mass equals. So we cover mass in the triangle. These two are on the same level, so we need to multiply them. So it equals n times m. Okay, thanks very much to Will for this great diagram on how to remember it. Moles live under the ground. Above is a church, which is your mass, a church, and your relative atomic mass here, RAM, stands for RAM, so there's some computer chips that have been buried under the ground as well. I like it. Thanks, Will. Okay, so there's 2 more questions, or part A and part B, that I'd like you to have a go at. See how you go. If you can work it out, go for it. Otherwise, I'm going to do the work solutions now for you. So part A. Calculate the amount in mole of carbon dioxide molecules present in 22 grams of carbon dioxide. The first thing you always need to do is read this like a little storybook. What is the information I can get from the question? The information I know here is that mass, little m, is 22 grams. Great. What else do I always know? I always know the molar mass because I've got the periodic table. You've always got the periodic table. So, molar mass of carbon dioxide we can work out. And I also like to write down what is the question asking me for. It's asking me to calculate the amount in mole. If I write this here, when I get to the end of the question, I can just go back and check, have I actually answered the question? So let's work out the molar mass of carbon dioxide, which will equal 1 times the molar mass of carbon, because there's 1 carbon atom, and 2 times the molar mass of oxygen, because there's 2 oxygen atoms there. So 1 times 12, and 2 times 16. Remember, these numbers here just come straight from the periodic table. So we've got 12 plus 32, which equals 44 grams per mole. Is that what the question asks you to find out? No, we're trying to find out the number of moles. So we use the formula. N is mass over molar mass, which equals mass is 22 grams divided by your molar mass, which is 44, which equals 0.50 mole. Double check at this point whether you've worked out what the question's asking you for. You've worked out the number of mole and your units match. Excellent, we can move on to part 2. So what is the number of molecules present in this mass of carbon dioxide? So what do we already know? We know that the number of mole of carbon dioxide is 0.50 mole. Now remember, that's just like saying that there's so many dozen eggs, okay? If I've got half a dozen eggs, I'd have 6 eggs. So we need to work out actually how many of these particles we've got. So what is the number of molecules? Okay, so the number of molecules is going to equal the number of mole times Avogadro's number. Just as if we were working out how many dozen eggs we've got or how many eggs we've got. If I've got half a dozen eggs, I'd multiply that by 12 to get the number of eggs. Here I'm going to multiply by Avogadro's number, which is 6.02 by 10 to the 23, because that's how many particles are in each mole. How many mole have we got? We've got half a mole, so half times 6.02 by 10 to the 23rd gives us 3.01 by 10 to the 23rd molecules. So the number of carbon dioxide molecules in half a mole is going to be 3.01 by 10 to the 23rd molecules. Okay, you should be able to complete now the questions in the booklet from 19 to 23 and Chapter 4 questions from 9 to 13.